The lines between virtual and physical worlds have been blurring since the first items were sold on the internet, and commentators tested e-commerce to try and survive in the real world using only what they could buy online. To Gen Z, which has never known a world without the internet and smartphones, the thought that this is recent history is astonishing. For many, the boundaries between physical and virtual worlds have already blurred. As technology continues to evolve, so does consumer behavior. Augmented reality, AR, has brought digital into the physical world in the form from a retail perspective, of viewing digital versions of products positioned within a buyer's room. It is now possible for a virtual outfit to be overlaid over your body while on a Zoom call, or even move with you as you strike a pose for Instagram. Having bought the sofa they've sized up using AR, a shopper can then put on a virtual reality, VR, headset such as the Meta-owned Oculus Quest, and visit Antarctica or the International Space Station. Worlds can be reimagined. The metaverse, referring to an amalgamation of meta and universe, is poised to take all this a big step further, although no one is entirely sure what it will become. One hypothesis is that the metaverse will bring together many different technologies, the internet and gaming to support persistent 3D virtual environments. It will combine VR and AR as access points, payments enabled by smart contracts. There is one metaverse within which are different verses, individual economies connecting across the internet and now bridging with the physical world. In Meta's words, the metaverse won't be built overnight by a single company. The metaverse will enable people to interact in virtual 3D spaces that, as in the real world, are run and operated by different people or companies. Their avatar, virtual persona, will be able to move between the different spaces. More importantly, these spaces or games will become platforms for experiences, a parallel reality where people can travel, hold meetings, go to concerts, interact and buy and sell things. There is no clear path to what the metaverse will look like, says Atkinson, although she hopes that it will be decentralized and open, as is the case with the first fully decentralized world, Decentraland. This world is controlled by a decentralized autonomous organization, DAO, so that the people who create and use the world have a stake in it and vote on how it evolves. The DAO owns the assets, such as smart contracts and real estate contracts. In this way, ownership of data is retained by the individual user. However, Meta wants to become heavily involved and bring the metaverse to life. To do so, it is creating 10,000 new jobs. Its ownership of social media and virtual reality software and hardware make it an obvious development for the company. Yet Meta already has pervasive insight into consumers' lives and there are worries about how it could try to control the metaverse, rather than allowing it to evolve openly and organically. It could become a very closed metaverse, warns Atkinson. Meta says it wants to collaborate and that other companies won't want to be left behind as this area progresses. There are many different technologies evolving currently that will form part of it, with NFTs offering a security point. Consumers will decide how, where and in what way they want to interact. People will use the metaverse in different ways. Earlier this year, back in March of last year, Boston Dynamics unveiled its second commercial robot, Stretch. The system, built from its impressive box-moving handle concept, is designed to bring the company's advanced robotics technologies into a warehouse/logistics setting, easily one of the hottest categories in robotics these days. Today the Hyundai-owned firm announced its first commercial customer, and it's a huge one. Logistics giant DHL has committed to a multi-year, $15 million deal, or investment as the parties are referring to it, set to bring the robot to its North American facilities. Specific details on the number of robots being purchased haven't been revealed, but Boston Dynamics says it's going to be bringing a fleet of the robots to DHL logistics centers over the next 3 years. Stretch will get to work unloading trucks to start, a feature its creators have highlighted as a vital part of its initial rollout. Additional tasks will be added over the course of the rollout in an effort to further automate the package handling process. Says CEO Robert Plater, Stretch is Boston Dynamics' newest robot, designed specifically to remedy challenges within the warehouse space. We are excited to be working with DHL supply chain to deliver a fleet of robots that will further automate warehousing and improve safety for its associates. We believe Stretch can make a measurable impact on DHL's business operations, and we're excited to see the robot in action at scale. The partnership will be a key proving ground for Boston Dynamics' commercial ambitions beyond its ongoing spot deployment. Package handling is an intensive, highly repetitive job that requires long hours of work, strain and multiple points of failure. This will be a major test for the company under Hyundai, which has sought to further its commercial ambitions. For DHL, meanwhile, it's an opportunity to automate some logistics roles during a time when blue-collar jobs have proven difficult to keep staffed. It's also a chance to more fully embrace automation as it competes with the likes of Amazon, which has begun steadily encroaching on the package delivery space. Hyundai has some grand ambitions for its robotics development. And thus far, the automaker has been willing to put its money where its mouth is, most notably in the form of its acquisition of Boston Dynamics, which valued the robotics pioneer at north of $1 billion. Robotics are. In the past few years, AI has evolved to become one of the most powerful tools in tech history to bring machines and humankind together. Back in the day, AI was limited to speculations and fictional stories. But in the modern state, AI is no longer confined to laboratories and scientific labs. Instead, it has become a part of our daily lives. Starting from search engines, call center chatbots, to AI-enabled humanoid robots, there is a whole range of artificial intelligence products and services that are available in the market, which has not only accelerated the growth in the functional capacities of the industries, but has also enhanced our existing living conditions. AI is a pressing priority in the modern era. Several government organizations and institutions are categorizing and identifying safe ways to deploy AI into their daily operations, and use more advanced technologies to secure the survival of their citizens. The COVID-19 is one of the primary reasons that has boosted the adoption of AI. As more government and business institutions are focusing on digital advancements, the implementation of artificial intelligence applications emerged as the predominant factor to drive the progress of this initiative. As the society adapts to the new changes after the pandemic, global citizens are expecting their governments to put the digital-first initiative as a priority. AI is also integrated into systems to tackle climate change issues, predict weather forecasts by scientific organizations, and eradicate food wastage, global hunger and poverty. For business institutions, AI has enabled the optimization of enterprise operations to make them more productive and efficient. Nowadays, the competency of a business leader lies in not only predicting the next actions of the competitors, but in staying updated about the next technological innovation, and how it can be implemented to boost business growth. Integrating AI in operational tasks has made senior executives understand the importance of leveraging such other advanced technologies like business analytics, data science, machine learning and SaaS, to perform key operational activities and collaborating beyond the boundaries of the corporate infrastructure and digital ecosystem. Early movers realize the importance and significant benefits of AI in this critical data-driven era. In the future, AI and machine learning can radically change the way we perceive work, by complementing and augmenting human skills. The entire work landscapes for both public and private sectors have changed by the implementation of cognitive systems that use feedback loops to perform more intelligent tasks. It is pertinent for all business and government infrastructures to culture an AI-driven mindset in the organization, encourage and incentivize employees to upskill their knowledge about emerging technologies, along with the advancements in their respective domains. GPT-3, the largest neural network ever created, revolutionized the AI world. OpenAI released a beta API for people to play with the system, and soon the hype started building up. People were finding crazy results. GPT-3 could transform a description of a web page into the corresponding code. It could emulate people and write customized poetry or songs. And it could wonder about the future or the meaning of life. And it wasn't trained for any of this. GPT-3 was brute force trained in most of the internet's available text data. But it wasn't explicitly taught to do these tasks. The system is so powerful that it became a meta-learner. And users could communicate with it in plain natural language. GPT-3 would receive the description and recognize the task it had to do. This was a year ago. For the last 3 years, OpenAI has been releasing GPT models yearly. In 2018 they presented GPT-1, then GPT-2 in 2019, and finally, GPT-3 arrived in 2020. Following this pattern, we could presumably be close to the creation of a hypothetical GPT-4. Given everything that GPT-3 can do and the degree to which it has changed some paradigms within AI, the question is, what can we expect from GPT-4? Let's get into it. GPT-3 isn't just big. The title of the biggest neural network ever created is very ambiguous. It could be just a tiny fraction bigger than other models. To put its size into perspective, GPT-3 is 100x bigger than its predecessor, GPT-2, which was already extremely big when it came up in 2019. GPT-3 has 175 billion parameters, which is 10x its closest competitors. Increasing the number of parameters 100-fold from GPT-2 to GPT-3 not only brought quantitative differences. GPT-3 isn't just more powerful than GPT-2, it is differently more powerful. There's a qualitative leap between both models. GPT-3 can do things GPT-2 can't do. From this fact, it's reasonable to expect that OpenAI continues with this trend. Making GPT-4 notably bigger than GPT-3, aiming at finding new qualitative differences. If GPT-3 can learn to learn, who knows what GPT-4 could bring? We might see the first neural network capable of true reasoning and understanding. GPT-3 was impressive at solving NLP tasks such as machine translation, question answering, or closed tasks in few-shot settings. In zero-shot settings, however, its performance wasn't as good. Expecting GPT-3 to solve a task it hasn't been trained on, without even seeing an example beforehand, may be too much to ask from it. Not even we, humans, can solve many tasks by pure intuition. GPT-3's strength is few-shot multitasking. OpenAI researchers acknowledged that few-shot results were notably better than zero-shot results. As Raheen Shah puts it, few-shot performance increases as the number of parameters increases. And the rate of increase is faster than the corresponding rate for zero-shot performance. This means that GPT-3 is a meta-learner and that the bigger a model is, the better its meta-learning capabilities. If we assume GPT-4 will have way more parameters, then we can expect it to be even a better meta-learner. One usual criticism of deep learning systems is that they need a lot of examples to learn a single task. GPT-4 could be the proof that language models can learn multitasking, from a few examples almost as good as we can. GPT-3 can understand that it has to continue a conversation without being explicitly told to do so. OpenAI released the beta API Playground in July 2020, for external developers to play with GPT-3. One of the most powerful features of the system is that we can communicate with it using natural language. I could tell GPT-3, the following is a story about the universe that a wise man is telling a young boy. The wise man is nice, helpful, and knowledgeable on cosmology and astronomy, and the system would continue the story without me telling it to. But not just that. GPT-3 would also make the wise man tell the story nicely, and make him appear knowledgeable about the universe. It'd also write the story in easy language because the man is talking to a kid. GPT-3 would get all this information with that simple sentence. Any person could infer all this, but an AI? It's incredible. Tech blogger Goran Branwen has a lot of similar examples in his blog. However, Goran warns that the results of these tests can vary in quality. The reason is that prompt programming involves sampling. And sampling can prove the presence of knowledge but not the absence. This is a problem because, as Gary Marcus criticized, not knowing when a prompt will generate a bad result underlines a deep drawback of the system. We could always find a better prompt, Goran would argue. But what is the point if we can't be sure if the result is correct or not? To find the limits of the system, we shouldn't give up if a prompt doesn't work, only if no prompt works. This is why we need to make GPT-4 more robust to bad prompting. Human-made errors will be there unless we standardize prompt programming, which will be most likely done in coming years. And even then, the limitations of these systems will come hand in hand with our incapability of extracting their true potential. A true artificial intelligence shouldn't depend so much on a good prompting in the first place. We, humans, also depend on prompting, but we can self-assess to find issues. If I'm doing an exam and the exercises are badly worded, it may confuse me. But I can realize the wording is bad and ask the teacher. GPT-3 can't do that, it would try to perform the task without realizing anything. GPT-4 may implement a way of assessing the quality of a given prompt. This is more science fiction than reality as of now, but we'll need to keep this in mind. A system that's incapable of self-assessment can't be called intelligent. If GPT-4 could express doubt and lack of understanding as in, I don't know, I'm not very convinced of my answer. GPT-3 is very powerful, but its memory is quite limited. A person doesn't forget things that happened yesterday. The Beta API allows the user to input a text 500 to 1000 words long, the context window, for GPT-3 to do something with it. This means the system can't continue a half-written novel or complete the code for a large program. GPT-3 has simply no clue of what is outside its context window. This limitation hits few-shot settings strongly because the user has to write different examples. In Q&A it may not be a problem as it's very repetitive, but in other tasks such as translating an article, it's not doable. GPT-4 would also have this limitation, but the degree to which its usefulness is narrowed by this would certainly diminish. Arguably, a more important issue is that even if we can fit our intentions in a few hundred-word prompt, GPT-3 is a forgetful machine. It finds it difficult to keep coherence intact over long texts. If we start writing an article and ask GPT-3 to continue indefinitely, it'd end up repeating ideas or even diverging to non-related topics. GPT-3 and the previous transformer-based models all suffer this restriction. Transformers are an old architecture based only on attention, no convolution, no recurrence that appeared in 2017. There are already better ways to perform these types of tasks. Warren argues that there are ways to improve the attention deficits of transformers. Simple transformers are a way to create super powerful language models, but may not be the only way or even the best way. These ideas could be implemented in GPT-4. It'd enjoy a larger context window and it'd allow users to feed the system with books, long-form articles, images, video, or audio. Here are my predictions of how GPT-4 would improve from GPT-3. GPT-4 will have more parameters, and it'll be trained with more data to make it qualitatively more powerful. GPT-4 will be better at multitasking in few-shot settings. Its performance in these settings will be closer to that of humans. GPT-4 will depend less on good prompting. It will be more robust to human-made errors. GPT-4 will avoid the limitations of early transformer architectures. The context window will be larger, allowing the system to perform more complex tasks. Scientists have made a major stride towards turning fusion energy into a viable energy source. The research could allow for the creation of a whole new kind of sustainable energy source that in turn could revolutionize the way we power our world. Nuclear fusion is perhaps best known as the process that powers stars. Researchers hope that it could be brought down to Earth and harnessed as a sustainable source of power. But creating it in laboratories has proven difficult. It uses far more energy than it produces, and so remains largely useless at a large scale. Now scientists say they have successfully built a process that allows for the self-heating of matter when it is a plasma state, using nuclear fusion, which could represent a major step towards the use of nuclear fusion. The research is described in a study, Burning Plasma Achieved in Inertial Fusion, published in Nature Today. An accompanying paper in Nature Physics describes how scientists were able to optimize their experimental design successfully. The breakthrough experiment is only an answer to only one of the many questions that surround nuclear fusion, and much work remains to be done. But it satisfied a key requirement for self-sustaining fusion energy as it has been envisioned and hoped for. In short, the researchers were able to compress and heat a plasma, which will then be heated by the reactions themselves, allowing the energy to sustain itself. To conduct the research, scientists took the hydrogen isotopes deuterium, which can be found in seawater, and tritium, which is made in a reactor. They used them to create a burning plasma. In a burning plasma, the particles that are made when the nuclei fuse then become the main source of the heating of that plasma. In 4 different experiments described in the paper, the researchers were able to generate more than 100 kilojoules of energy. In one of them, the researchers got 170 kilojoules of energy from a sphere the size of a millimeter, which contained less than a milligram of the isotopes. Though that is far more energy than was put into the fuel, helping to overcome the perennial problem that nuclear fusion actually uses more energy than it produces, it is still only a relatively small amount in total. the cavity containing the process and the laser required to heat it still use far more energy.